Today we're going to take a look at the volumes of solids with known cross sections. Number 1, the volume of a solid whose base is x squared plus y squared equals 4 and a cross section is perpendicular to the x-axis and our squares with sides lie on the base of the circle. So here, this is the base of the solid is a circle. So imagine this, you've got a circle. All right, and what do we know about the circle? The radius is 4. So you should recognize that, or the radius is 2. The center is at 0, 0. All right, and it looks something like this. So what we've got is, what they're saying is the cross section is perpendicular to this circle is square. So basically coming out of this, we have a square. We have all these squares. All right, and we can take the area of squares. All right, so however, be careful. Remember this curve right here. So we've got these squares that are coming out of here. However, remember in our calculators we can only put in the square root of, or y equals, and we put in this part and we put in this part right here. Okay, when we go to solve this, and I think you can go solve this for y, we get this top to be 4 minus x squared, and we get this bottom to be negative square root of 4 minus x squared. All right, think of this as like part of a parabola right here and part of a parabola right here. All right. So just remember that. Now, we're talking about a square. Well, what is the area of a square? Well, a lot of you will say base times height, or it would be side squared. I'm just going to put x squared for the side squared. This is the shape we are integrating, and that we're taking the cross section of. All right, so if I tell you it's a triangle, we'll have the area of a triangle right here. All right, and we will be integrating it. Now, we want the volume. All right, and we're going to do it from -2 to 2. But notice one side of the square, and think about this right here. Since we've got two functions going on here, we really just want one of them, and we can times it by 2. So I'm going to take the square root of 4 minus x squared and times it by 2. This is the side, okay, of our square, and we're going to square it. So this is kind of like the formula for the side squared, and we just plug this in for that x. All right, and we do dx right here. Now, when I actually do this out, we can get the volume to be -2 to 2, all right, of 16 minus 4x squared. All right, how I got that is I square the 2, which is a 4, and when I square this, I'll have in parentheses 4 minus x squared, and I distribute that 4. And so this actually isn't bad to integrate, so I'm going to let you integrate this on your own. And we ultimately end up with the final answer to be 128/3. All right, we've done a lot of integrating. We've done it by hand, so be able to do this by hand. And I think you can get to the 123. All right, number 2, we want to do the same problem. All right, but this time, instead of it squares coming out, we want equilateral triangles. All right, so we would be having this circle. Looks like this. And instead of like this being a square coming up and out and over, it would be an equilateral triangle would be coming out of here. So this would be the shape would be an equilateral triangle coming out. All right, well, let's think about the area of a triangle. The area of a triangle is 1/2 base times height. However, let's think about an equilateral triangle. We're actually going to have to figure this thing out The square was easier because it was side squared. All right, but let's think about this for a second. This is the side. All right, well, I've got to figure out what the actual height is going to be. Okay, or I can think of this as the base, if we want to put the base right here, instead of putting it as an S. All right, so to figure out the height, remember, what type of triangle is this? All right, well, that's 60 degrees, so a 30, 60, 90. All right, and think about this. This part right here is going to be the base divided by 2. Okay, so the height is, if you remember the 30, 60, 90 triangle, it's whatever is across from 30 times the square root of 3. So base over 2 times the square root of 3. All right, so when I plug this in, it's 1/2. You got the base. All right, and then the height is base square root of 3 over 2. All right, so what does this equal? Base squared over 3 over 2. So this is what we're integrating. All right, this is what we're integrating right here. Or actually, it's over 4, sorry, because I should have done 2 times 2. All right, so we're going to do the volume. The volume from -2 to 2, because remember, -2 to 2 right here on the x-axis. All right, I'm using x. The base, and I'm going to go ahead and pull out the square root of 3 over 4. The base, remember, it's 2 of these. All right, so it's going to be 2 times the square root of 4 minus x squared dx. And you could try this by hand, okay, or you can try plugging it into your calculator and figuring out what we get. We end up with 18.475. All right, so pause the video for a second and see if you can either do this by hand and integrate it or go plug it into your calculator. All right, our next problem, number 3. The volume of a solid bounded, so this time we're looking at a different picture. Okay, it's bounded by this graph right here and this graph right here in x equals 0. So if we need to, we'll all right, the y-intercept here is +1 and it's the slope of -1/2. So down 1 over 2. All right, it is great if you actually have graph paper. All right, here, -1, up 1 over 2, up 1 over 2. All right, so you got a line here, you've got a line here. All right, and it says bounded by x equals 0, so this right here. So it's actually this region right here that we're finding the volume of. All right, but again, we're doing it through equilateral triangles. So basically, each thing coming out of here is going to be an equilateral triangle. All right, so if you remember what we just did, the area for the equilateral triangle was b squared, square root of 3 over 4. All right, so this is what we are integrating. All right, we're doing it from the x's from 0 to 2. So my bounds should be 0 to 2. I'm going to pull out the constant, square root of 3 over 4. All right, and remember when we do the volume, we are doing the top one minus the bottom one. All right, so the top one is 1 minus x over 2 minus the bottom one. All right, and then that's squared, and don't forget your dx. Now, go ahead and clean that up. And if you clean it up, you end up with 0 to 2, the square root of 3 over 4. All right, 2 minus x squared. All right, dx, and I'll let you integrate that either by hand or on your calculator. Make sure you can do some of these by hand. And then some of these on the AP test could just be setup. All right, so this could be an answer if it's asking you just for setup. So ultimately, we end up with the answer 1.155. So check your answer to see if you get that decimal. So I'm focusing on really how do we set this up, all right, using the cross sections, and not necessarily how do we solve a definite integral. All right, I think you should know that by now. All right, number 4, find the volume of the solid whose base is bounded by the graphs of, so we got a linear function right here, and we have a quadratic function right here. All right, with cross sections taken perpendicular to the x-axis as rectangles. All right, so here we go. Let's take a look at this picture right here. All right, the y-intercept is 1. It's down 1 over 1. All right, sorry it's not that straight of a line. All right, and then let's see. We've got that vertex is at -1. When I plug x equals 1 in, I get 0. Same thing here. Let's see, when I plug in 2 squared is 4. All right, so they actually intersect right here. All right, a rectangle, the area is base times height. All right, here you've got this. This is the cross section. All right, and we're going to say our height is 1 with the rectangles. All right. And then our base, okay, what is our base going to be? Well, remember, it's the top minus the bottom. All right, so we're going to do x plus 1 minus x squared minus 1. Well, when I distribute that negative, all right, I end up with negative x squared plus x plus 2. All right, so this is our b value. All right, notice our x values, we're going from -1 to 2. All right, and since we're timesing about 1, really it's just going to be negative x squared plus x plus 2 dx. All right, you go integrate that. Pause the video. And you should be able to do this one by hand especially, you should be getting 9 over 2. And lastly, the base of a solid is bounded by y equals x cubed, y equals 0, and x equals 1. Find the volume of the solid for each of the following cross sections taken perpendicular to the y-axis. And they're going to be semicircles. So take a second and see if you can start drawing that picture a little bit. All right, here the y-axis, or y equals 0, is going to be the x-axis right here. X equals 1 is right here. Okay, and then here Remember, when I plug in 0, I get 0, 0. When I plug in 1, I get 1, 1. All right, so it's going something like that. So it's this area right here. And we're doing it as semicircles. So you would basically have the base of the semicircle would be here and it would be coming up. So you would have all these semicircles right here. Okay, so semicircle, think the area of a semicircle is pi r squared is the area of a circle, and semicircle we divide by 2. All right, now we need to think of the whole thing would be the diameter. You just want half of it for the radius. So you've got to be very careful on that. So pi over 2. All right, and the radius, think the top minus the bottom. All right. So the top minus the bottom would be x cubed. All right, minus 0, because that would be 0 right there. All right, however, you got to divide it in half. Okay, so I would be going from the x values of 0 to 1. All right, I'm going to pull out the pi over 2. All right, and then when I square this, it becomes, let's see, x to the 6th over 4. And I would integrate that right there. All right, when I integrate it, I ultimately end up with pi over 80. Okay, or it's 0.039. Now on this one, I could also change it. So this would be in terms of x right here. I can also change it in terms of y. All right, if I change it in terms of y, then I have to take this and I have to solve it for x. All right, and so when I do that, that's taking the cube root. All right, and remember, when I do it that way, if I'm doing y's, okay, along the y-axis, that's also 0 to 1. All right, remember we're doing from right to left, so I hit the x equals 1 first, minus this part right here, the cube root, and remember the radius is half the diameter, so I have to divide by 2. And that 3 is the cube root. It's a kind of a large 3 right there. So you can also write this not only in terms of x, you can write it in terms of y. And you should be able to get the same answer. All right, but double check your work. So this is volumes of cross sections. Know what the area formulas are for the different shapes that they give us. Be able to set it up. Sometimes they'll ask you for setups in these.